our fourth and final session, and today we are talking about valid arguments. Now, an argument is made up of propositions that lead to a conclusion, and they're usually indicated by the words therefore or hence. The best thing to do is just to really look at an example. What conclusions result from the sentence, Kiwis cannot fly, Emily is a Kiwi? What is the logical conclusion? Well, the logical conclusion is that Emily cannot fly. So how do we set this up with the language of logic? Well, we let our first proposition be P, that Kiwis cannot fly, and our second proposition is Q, that Emily is a Kiwi. And the argument can be written as this. We want P and Q to be true, and we call that the premise. And that we set that up, you may not be able to see that, but there's actually a line there. Above the line is our premise, and our conclusion is below the line. And arguments can have their validity tested by analysing the premise and its conclusion. Now, a mathematical argument assumes that all the premises are always true. It's not concerned with that. It's only concerned with what can validly be inferred from them. In logical form, the Kiwi argument becomes, well, we want P and Q to be true, and that will imply that Q is also true. So, the premise is represented by the and on the left, because this was the things above the line, and the argument is represented by the truth values of when you're using the implication of the answer to this and the implication of Q. And this is really important. By showing that the logical form is a tautology, we demonstrate that the argument is valid. And remember, a tautology is when you've got that final column in your truth table, that they are all true. So let's show that. Now we're going to be using our truth tables in a slightly different way. We're going to be setting it up so that we're going to put our answer to our premise in between them here. And then we're going to put our answer to our premise and get our conclusion and put it here. So let's have a look. Remember, we've got the conjunction of P and Q. Remember, it looks like a giant and. So we only get a true value when both P and Q are true. So looking at just P and Q, that's the only position where we've got two truths, and everything else becomes false. Now we've also got implies Q, so we know what Q is, and we're looking for the answer to this. So we're looking at this column here, and we are using the implication of that answer with Q. And remember the implication. The implication is true, friends forever. Everything else is true. So get the order right. So we want true there and false here. And that will give us our false. Remember, true, friends. So that's the TF that we need. Will give us a false answer. Just true, friends, forever. So let's have a look. We've got TT, so that's not going to work. Okay, we don't have a TF in that order. Okay, true, friends, forever, everything else is true. If that's the case, we have got no false outcomes, so everything is true. And this becomes our final column in our truth table. Everything is true, it's a tautology, so that argument is valid.